Welcome, dear students. This is your lesson 2 of your plotting of graphs, in fact of your trigonometry graphs. And here we are going to actually plot the graphs themselves. We're going to mostly use the calculator to do it, and then we're going to also solve some equations. And of course, towards the end, I'll give you the practice questions for you to do. So let's dive right into the content and see what I'm expecting of you. So if you look at this one, this is the first example that we have. We want to sketch two graphs in this situation. We want to sketch the graph of function of x is x minus 30, as you are noticing cos x minus 30 right there. And we would like to just see if we can sketch those two on the same set of x's. Likely we were given the domain that is from minus 90 to 90. So I already have a graph paper prepared for this. So you all can also take your graph papers so we can sketch these graphs here on the graph paper. So you want to use the same scale and everything here. So there are a few things I want to point out before we start using our calculator to solve. You see, we are going to see something where the calculator will ask us to start, where to start. You're going to start at this number that's given there. When it asks you for when to start, you say you would like to start to draw the graph from negative 90 degrees. When do you want to stop? You want to stop at 90 degrees, just as the domain has specified. Well, there is something called the step as well. So if you'd like to know what a step is, especially when you're drawing the cosine and the sine graphs, well, the step, you get it by saying 90 over b. You still remember b is the coefficient of the angle. We spoke about that in the first lesson. So in this situation, let's say I look at gx, my b there is 3 because there is x there in place of our angle, so there is 3. So it means if you want to have your step there, it will be 90 divided by 3, which will be 30 degrees. However, another way, something that can override the formula of 90 over b is the shift. So you can see here on this one, when it says x minus 30, it means the graph of cosine of x has been shifted 30 degrees to the right, as was explained in your first lesson. So please people, here the shift is what you also have to respect. So if let's say this function gx was saying let's go 45 degrees, and this one the shift is 30 degrees to either side, either left or right, you were going to actually go with 30 degrees on your step. Well, that is what to know about the step. So why don't I show you where those things are actually asked? So what are you going to do in the situation of ours? Let's go to our first example and let's see if we can put it on the calculator. So I have a Casio calculator here with me, and I hope you also have yours there. So yours looks plus minus this one, and it's just a few differences here and there. So to get started with sketching graphs, you have to first of all set up your calculator in such a way that it can take your function in. So on your calculators, I am checking yours is on number 3, the table mode. So it's on number 3. So you have to press 3 as I press 7. You press 3, and then you go to where it's asking you what is your function of x. So you have to go and press, well, mine is cos x minus 30. To get the number there, you press alpha and then you press the close bracket. Okay, so that's how you get x in there. And then of course you want to say minus 30. So you can do things a lot faster there. I believe you can. So I put our function of x in. So what you need to do next is to press the equal sign. If you do that, the calculator will prompt you to put another function. So in this situation, if you don't have another function, you can just put 1 here, and then you just go to the next step. Just press gx is equal to 1. But since we have a function here, we're going to put sine of 3x. So you have to press sine there, and then of course you know there is a 3. So let's just find 3, and we would like to press x. So you press alpha again and press the close bracket, and that is what we have for our gx. What you then have to do is to press your equal sign. Like I said, it will ask you where do you want to start. Well, since on our first example we were asked to start on negative 90, we just mentioned we would like to start on negative 90 degrees like this, and then we press equal sign to ask you where do you want to end. Well, we would like to end on 90 degrees. That is what the domain said before. I hope you looked at it before it was covered by my calculator there. So after you put that, you press equal sign. Now it's asking you for the step. Well, the step can be determined by whatever shift has been given there, or by the b that is over here. So 90 over b. So in this situation, we have already discussed that our step must be 30 degrees. Okay, so that's the step we need. When you press the equal sign, you will get those values, and what you will then go and do is to go and plot these numbers that you see here. So you go to negative 90 for function of x, you go to negative 0.5 and you sketch it. You go down all the way to the last one, and then when you're done, you can also go and do the ones for gx. So just make sure you do it correctly right there. So I am going to do mine. I don't know if you would like to look at me doing it. So if you'd like to do so, maybe let's go ahead and do it together. Let us put these points on the graph paper quickly together. So what we are going to do is to take our calculators like we have already indicated. We go to negative 90. So since this is your first one, I am going to actually just do it with you. So with your calculator there, let's sketch function of x. I believe you have it, and then you are ready to actually get it with me. Actually, let me do this. Let's go and put on negative 90, we are going to go to negative 0.5. So I am here on negative 90. So negative 0.5 is some 5 boxes away, some 5 boxes down. So that will be at that point. So I believe you can sketch, but let's just do it together for this one. On negative 60, I'll be on 0. You can do it. And then on negative 30, I'll be on positive 0.5, which will be over here. And then on negative, on 0 itself, I am on 0.866. So you see, when you have 0.866, you have to approximate a little. So you know this is 0.5, this is 0.6, 0.7, 0.8. So the next one will be 0.9. So if you want 0.866, it means you have to be somewhere in the middle here. Close to 0.9, but not right there. So that's the point you are looking for right there. Okay, so that's 0.866. 30 degrees, you are on 1. So now you are right on 1 right here. So you put your number over there, and then now on 60 degrees, you're back to that one where you have to approximate. We said we'll put it at this level. And then the next thing is 90, which is on 0.5. 0.5 is that one on my graph paper. So you find something which is like a graph paper or anything that has got something you can use scale properly, and then you can have this graph. So what you only need to do is to join those ones. So feel free to join them, and if your graph is smooth, it's just better that way. If it is not, then well, we try to forgive you as well, since it's not always very easy to go through all points. So that is mine. I missed that point. I don't want to miss that point. So let me just try harder there. Okay, I'm going to try and do this. Okay, I believe yours, let's stick with yours for now, because I doubt we have enough time to carry on doing this. All right, so that's the graph I'm going to settle for. So that one, we are going to just call it our function of x right there. That is our function of x. We just finished sketching it. So after you do that, go and sketch your gx. So we are going to do it together, right? So I'm going back. You scroll on your calculator, go back to negative 90, and then on negative 90, you will notice that it starts on 1, this one. So gx, when x is negative 90, y is actually 1. So just on that line over there, that is your 1. And then from there, from negative 60, you go to 0. It comes at this level. And then negative 30 goes to negative 1. It is not very bad. It's an easy one to sketch. After that, there is 0 and 0. then 30 and 1. I'm sure you're looking at the same. It's more like a point of intersection that we are seeing there. And then 60 is back to 0. And then the last one, 90, is on -1. So -1 is on this level right there. So I'll just go and join my dots, my red dots, which on yours maybe you have some crosses or whatever it is that you have. So you just sketch. That is precisely what you do when you're sketching. So I'm going to try and join these points. Okay, that's what I could do for this one. So this one is the one that we are going to call GX. From what we have, that is our GX right there. Now, these two graphs, we sketched it, and normally then we already have our marks that they want for sketching, maybe 5, maybe less or more, depending on how much work is needed to sketch it. So you manage to sketch a function of x and GX on the same set of x's from -90 to 90 degrees. And then after you do that, you realize that there are certain questions that they love asking concerning these ones. They just love. They won't let you go without answering questions such as these ones. Like, for example, for which values of x is function of x equal to gx? They are hinting on you finding a point of intersection. From functions, we know that they want the point of intersection right there. So for this one, it's very easy to answer because you can see your points of intersection from the graph so easily. You can easily see that these graphs are intersecting twice in the domain given, that is from -60 degrees, and also at that point here, which is 30 degrees. So those are our two solutions that we have in this domain. So you can just write it's -60 over here and also 30 degrees. That was easy to find. But notice it's not always that simple. Most of the times the graphs that they give you, they intersect at a place where you cannot guess what the x value is. So you are expected to be able to solve equations such as those ones. So what I'm going to ask us to do is to say, well, if we didn't have such a graph, were we going to if it wasn't so easy to read out the 30 degrees and the -60, were we going to be able to find that using our equations that we learned before? Well, I'm sure you want to see if that is possible. So let's just quickly do it here. So when we solve a question such as function of x is equal to gx, we don't struggle with that. Remember, our function of x was cos x minus 30, right? And then you put it over there, you equate to gx, which was sine 3x. Now this is an same old trigonometry equation. Check our trigonometry equation series, please, and learn how to do these. Well, if you remember those, you would remember that I said whenever you have two functions, that's the cosine and sine, two different functions, and again, two different angles. You see here we are dealing with x minus 30, and on the other hand we have 3x. It's not the same angle, so you cannot divide by cosine this time. However, what you do this time is to change the function into one function, which in this situation you will change this to cosine. But which value is sine 3x equal to? Well, it is equal to cos 90 minus 3x using your cofunctions, isn't it? If I write cos 90 minus 3x, if I ask you to reduce it, you will say, well, it is equal to sine 3x. So we are using that fact to make sure that we have the same function on both sides. After we get the same function on both sides, we do the step which I called dropping the cosine. You are taking the arc cos both sides, so you'll be left with just the angle. In your head, I know you're busy cancelling the cosine. It's not what's happening, but the cosine falls away. So what will be left will be 90 minus 3x on this side. If I just solve this equation, I'll get one x value, which will not give us everything that we need here. So to make sure that we get every other solution there is, we're going to do a general solution. And for cosine, we say the general solution, you put a plus or minus in front of the second angle that you have, and don't forget to say 360k. The reason for this is because of those negative angles. Remember, we said cos of negative a is equal to cos a. So the angle you have, you can as well call it plus minus. It will give you the same cosine. Okay, so here remember your k is supposed to be an element of integers. You can substitute any integer to get what you want. So this is you solving an equation. You are allowed to solve an equation, especially if it is not so easy to see your points of intersection. If they ask you for points of intersection and they give you 6 marks, definitely that question won't be for you to check on your graph where the graphs are intersecting and approximate. No. You have to give the exact one. So in this situation, we are just going to finish this off. There are 2 general solutions here, I believe. There is the one where we use the positive, so we'll just be left with 90 minus 3x plus 360k. And then there is another one which we are going to use the negative, and that one will be x minus 30 degrees is equal to negative 90 plus 3x plus 360k. Okay, we want to just keep everything sorted over there. So to finish this off, I'm going to just come here. Let's solve it. I'm going to take 3x to the other side. Definitely you can see that. That will become 4x. 90 plus 30 will become 100. Is that 120 people? And then plus 360k. Okay, this is you doing some math now. Now dividing everything by 4, that will give you a general solution of x is equal to 30 degrees plus is that 90 when you divide that by 4. That right there will be your first general solution that you can use to find any value in any given domain where these 2 graphs are intersecting. So at this point, we know that we will just have to play around with a few k values there. Let me just solve the other one. With a negative on the other side, at this point, I can see all I have to do is to take 30 to the other side. It will leave negative 60 degrees plus, oh, excuse me, is that a 3x that I am seeing over there? Okay, since the 3x is on the other side, I will have to bring it to this side, isn't it? Let's first of all bring it to this side. So x minus 3x, I'm saying take that one to this side. I'm sure it will be negative 2x after that. So now you are allowed to say negative 90 plus 30 degrees, which will be negative 60 degrees plus 360k. Now let's get x. Your x here, if you divide by negative 2, as we will all the time, we will again get 30 degrees. Not very interesting. It's the same one, but let's see if it will still be the same. I'm sure you are aching to write it as negative 180k when you divide by minus 2. But from what we indicated when we were doing equations, you can leave this as positive. Since k can be any can be an element of integers, it can be a positive or a negative number, it will not affect much there. So this right here will be your general solution as well. Now, how do I use it? Remember, I am working from negative 90 to 90. So you play around with your k values until you get all the values of x that you need. So in this situation, it's interesting to carry on like this because I actually know the answers already. So at this point, I'm sure you don't even want to put a k value of 0 there. Please put a k value of 0 and see what you get in this equation. As you can see, you'll get 30 degrees, and since it is in our domain, I'll write it down. Well, put a k of negative 1. You see, why didn't I carry on and say put k of 2? Because I'm saying if you put 2 here, you get 180 plus 30, which will be more like 210, which is definitely not in our given domain. So we cannot carry on keeping k. We cannot increase the k value anymore. We can go down, however, from 1. I've already tried 0, so I'm going to go and what did I say? Did we try 1? Well, 1 will give us 120, which is not in the domain. So let's quickly see if we put negative 1. So if you put negative 1 in place of k, I'm seeing that you get negative 60 degrees here, and negative 60 degrees is in our domain. Well, since we know those were the 2 answers only, please don't close it before you check the second one. You can also check the second one by putting k of 0. As you can see, you still get 30 degrees, which is already there, so there is nothing new. And then you can put k of 1, which won't work. Put k of negative 1, which will not work either. So as you are noticing, these will be the only answers to this one. Okay, so this is what you do if you cannot just read from your graphs the points of intersection. Okay, so at this point, this is how you sketch your graph. You get your marks for sketching, and then after you get your marks for sketching, you have to be able to handle stuff such as this as well. When is the function of x greater than 0? We are saying when is the function of x above the x-axis generally. So let's go to the function. It's the blue graph. When is it above the x-axis in the given domain? Well, we can see that the only time it is below, it is at this area here, where from -60 going to the left. Every other time it looks to me like it is above the x-axis. So in this situation, because it's stopping on 90, we're just going to also mention that, well, we are moving from -60 all the way to 90. It is above the x-axis, so it's between those two numbers. This one right here, it was going to still be on above the x-axis for some time, but because our domain stopped, we're also going to stop. So x is between -60 and 90, and you just put that one, those signs. Okay, well done. If you could do stuff like this, it means you are sorted. Oh, actually there is question 1.3. We don't want to leave it out, where we are asked for the period of g. Do you still remember what g was? Well, let me show you what it was. It was sine 3x. How many of us have got a good memory from our lesson 1? If you have gx is equal to sine 3x, you remember how to get the period, don't you? Period for these ones, you say 360 divided by b. So your b in this situation is the coefficient of the angle. So in this situation, you say 360 divided by 3. That must be 1 there, 2 there, and 0 there. So the period of that function must be 120 degrees. Okay? So since you now grasp this, I hope you are actually grasping it. Let's go to the second example and see if you can do something over there as well. So let's go and sketch another one. Why not? Okay, if you are here, let's repeat the same process and see if you got the point of you using your calculator to get the points that we want. So what you need to do is to again go to your calculator. You want to sketch those two graphs on the same set of axes, but make up your mind before you do anything. As you can see, for function of x, do you see your b here is equal to 1? So function of x is busy saying, let's go and say for the step, you know, the step, you have to ascertain what your step is going to be before you start pressing anything. So b here is 1. So 90, function of x is saying, you know what, let's use a step of 90 degrees. That is what will work for me. And then g of x, the b value is 1, but there is a shift that took place here, which is 45 degrees. You practically have to respect that shift in your step, otherwise then you will fail to draw such a graph. So because the shift was 45 degrees, the step here that gx suggests will be 45 degrees for us to sketch it easily. It will be so easy to sketch function of x with a step of 90, but unfortunately we have to do it on the same set of x's. We have to kind of force function of x to fit on a scale of 45 degrees. You take the smaller one of the two. So here we have two conflicting steps, so we take 45 degrees rather than 90 degrees, since it's bigger than that. So our step is going to be 90. Where we start, it's going to be -180, and we're going to stop at 90 degrees. Everything else is easy there. So why don't we jump on our calculators and quickly see, go and do it quickly and see if you still remember. So I am going to go and I am just going to still put my function of x. Now I have a new function of x this time, and it does look like that we should be cosine of x. Remember, we alpha there, and then we close that. That's our function of x. We press equal sign. We put gx, which is also like just sine. It's alpha there, and it's x. Okay, that's your x, and then plus 45. Okay. Sure, I bet you press these things faster than me. Right, so you press equal sign. It's just asking you where to start. You have to overwrite what was there before. That is because we didn't reprogram it. So it's going to be -180. That's where we want to start. Okay, So after that, you press equal sign. You would like to end on 90 degrees. So let's put 90 over there. Right, and your step, the previous one was 30, we can see that, but don't worry, we are going to change it to 45 just now, and then it will give you what we need. So we're going to go and sketch those numbers together, and then on this graph, and then see what's what. I don't know if you still want us to do it together. I think let's just finish the whole thing doing it together, I guess. Okay, let's go ahead and do it on the graph. Okay, let's see. Right. So you can start sketching yours. I'm starting with function of x. So negative 180, I'm here on negative 1. So let's go and do it. Then negative 0.707. So 0.5, 0.6, 0.7. So if it's negative 0.707, so after those two, before you go to 0.8, just there, you know, just there, to make sure you put it there. And then negative, let's quickly see what's what here. I am putting it on negative 135. That is the correct place to do. Negative 135. 1, 2. Okay, and then on negative 90, 0. Negative 45. Okay, I think you can sketch this now. Negative 45, you just go 0.5 is here, then 0.6, 0.7. It means 0.701 will be somewhere over there. So I'll go ahead and sketch everything without you, and then you all can just sketch yours and then you compare with mine. Okay? Okay, I'm done. And as you can see, I used these points here that we had on the calculator, and then I used them to sketch function of x as well as g of x over there. So I'm sure you have plus minus the same type of graph on your graph paper. And as you can see this time around, though, you can tell now that it is not very simple to see your points of intersection anymore. Although you collected maybe all your marks for sketching the graphs, you may then fail to find your point of intersection. It is not easy to answer those same type of questions now. You can try to guess. You can see it is close to negative 180. It is between minus 135 and minus 180, but you can't quite tell exactly what that one would might be, because you know, as you sketch, this one is also, you look at that point of intersection over there, it's even in between the boxes, so it's very difficult to figure out what it is exactly. So what I just mentioned a few seconds ago is precisely what will work now. So to answer a question such as this one, we'll have to do it algebraically this time around. At least we have an idea. We know our answer should be smaller than 45 degrees. So if we by any chance make a mistake and our answer is 60 degrees, then we know that something wrong is happening there. So let's quickly go and solve those two equations that we have. Function of x is over there, gx is over there. So let's quickly solve that here. So when we want to solve a question such as a, we would just write our function of x. I hope we still remember what that one is. So that was cos x over there. That was our cos x, and then our you see our gx was sine x plus 45. The process is the same here as well. So if you want to finish this easily, what I said was you change the sine to cosine using your cofunctions. So you're going to say 90 minus x plus 45 degrees. This is you doing your equations. Well, at this point, let me just simplify it a little. It will be cos, then 90 minus x minus 45, so it means it's 90 minus 45, which is 45, and then you write that minus x that is there when you let the negative into the bracket. At this point, you drop the bracket, and your x will be equal to plus or minus 45 minus x plus 360k. I believe you still remember why I'm doing what I am doing. All right, so at this point, we have two general solutions that we can work with. Let's just have the one with a positive sign. So the one with a positive sign will say 45 minus x, it won't change, plus 360k. Okay, and then if I take x to the other side, it'll be 2x is equal to 45 plus 360k at this point. Now if I divide by 2, then I'll get 20 is at 22.5, right? 22.5 degrees plus 180k. So this right here is a general solution we are going to use to calculate those points of intersection. We normally do it for when we are calculating equations, but it's the same thing here. We also have our domain we have to take care of and then see if we're going to get something. Let's work with the negative sign and see what happens. Is equal to, if I take negative and say 45 minus x like this, plus 360k, does it even solve? So here we have x minus 45 plus x. Okay, nothing is going to come out of this one. Can you see that the x will cancel on both sides, and therefore there is not an if we are not solving for x, then what are we doing? You see, if x cancels, then there is nothing left. So we have this general solution to work with. So what we do is we play around with the k value. So notice, remember our domain is right here. We are from negative 180 to 90. We want to know all the points of intersection in that domain. So if I put k of 0, do you see I'm getting 22.5? I know that that is a solution. It is in the domain. If you put k of 1, you will get something way more than 90 degrees. So you actually get 105 degrees, and no, rather 102.5 degrees if you put k of 1. So there is no need to go up, since going up, since you see k of 0 worked, k of 1 did not work. We cannot use that one. So if we cannot carry on going up, we go back down. So we're going to put k of negative 1 and see if we're going to get anything interesting. Well, we are getting negative 157. It is in our domain, negative 157.5 degrees. So I guess we are going to take those. We know that there are two of them, so we don't even have to try and put negative 2 because it will be smaller than negative 180. So those right there will be the two values. Will be so if you want to answer this one, so you eventually just say, well, that is x of 22.5 and also x of negative 157.5 degrees. That is what you do using this process. So let's see if it makes sense on the graph. 22.5, definitely it will be this point here. If we're going to call it point A, it means this is where the 22.5 degree would be. And then the y value, we wonder what it is, but it is smaller than 1, as we are noticing. And then here must be the one that is that negative 1. It was negative 157.5. It must be here. So this is negative 157.5 degrees, as we are noticing. So that right there is the skill you need to carry on. Okay, so that is what we do. So is there questions? Is there any other interesting question? Well, that function of x is greater than 0. I just repeated kind of the same question. So if you want to find when function of x is greater than 0, you figure out when function of x is above the x-axis. Well, this whole time it is above the x-axis. This whole time function of x is above the x-axis. So you need all this time. So it means you're working with that x value and this x value over there. That is the time when it is above the x-axis. So you're just going to say, well, that is when x is in between is that negative 90 degrees, as well as when it is, what is that one? That would be 90 degrees. We don't want it to go below the x-axis. So what it means is that if I ask you for function of x is smaller than 0, you will be handling whatever is below the x-axis, isn't it? You give us the x value when the function is below the x-axis. That must be simple to do. Let's see if we still have anything on this one. Okay, let's go to our very last question, and then you're going to have the last bit of practice before we call this lesson off. So here is another place where you can actually plot your graph. So quickly go, now that you know what to do. I'm going to do it with you for the last time now, and then we're going to take our calculator again, and then we put our thing. So it does look like I have to start again. So our function of x this time is cosine of 2x, cos, and then you have your 2x over there. Okay, and then your gx is 2 sine, and then we have to put x there, plus 1. That plus 1 is not inside the bracket, so make sure you're doing it right. Okay, that is what we have. So for this one, did you check your domain before I did? So for this one, we are actually starting from 0 degrees. So let's start on 0. And then we are going to end on, I wanted you to end on 360 degrees. I believe I just didn't get space here. So I am going to end on 315 for my spacing. You can end on 360, it's not a problem. So did we talk about the step before? Well, while we are still here, I believe you can see that the b value here is 2, which will say 90 divided by 2, which is 45, and here b is 1. So we are going to continue to use that same 45 that's there, because we have 90 and 45. So on your own, quickly sketch those graphs, those two right there, or maybe we can even try do that one together quickly. So let's just do this one together. There is something interesting about it that I want you to see. Okay, let's sketch it together quickly. Okay, as fast as we can. So we need the whole thing, I believe. Okay, let's quickly start with function of x. On 0, it's on 1. So function of x, let's use blue. So on 0, we will be right here on 1. And then on 45, it's right on 0. So let's just quickly put that one. And then on 90, it's on -1. Okay, you won't be able to see everything here. And then on 135, let's go back to 0. Then 180, we are on 1. 1. Okay, and then 225, we are on 0. An interesting graph, really. 270, we are on -1. Uh-oh. Okay, and then on 315, lastly, we are on that random number, or we are on 0 actually. We are on 0. So let's just quickly sketch this one and see how it should look like. So this is our function of x in this situation, and it does look like this. Whatever I do, just draw it smoothly without breaking. It's just better that way. So if you break it, normally it's not as smooth as it should be. So just avoid that, but okay, I have my function of x. So now the graph that I want you to see is the second one. Now, this one, if you saw that it had 2, which actually is the amplitude. It is an amplitude of 2, but then it has that +1. You see, let me just show you what I mean. So do you see there is this 2 here? Normally that would be the amplitude. Under normal circumstances it will go to 2 and also to -2, but there is this +1, which means it was shifted again 1 unit up. That is why we are going to expect it to go all the way to 3. I expected it to go to 3, that is why my graph goes all the way to 3. So what we are going to do is to now sketch this. Let's do it as fast as we can. So on 0, I am seeing that I am also on 1 for this one. So I'm going to go right on 1. It's already a point of intersection. And then on 45, it's on 2.41. So I want you to be able to see how to put 2.41. So what we see is that this is your 45-degree line, and then this is your 2.5. You don't want to be on 2.5, you want to be on 2.41. So 2.4 is just down there. So you want to make sure that you put it somewhat above. So do your approximations properly. Shouldn't be on 2.4 either, should be on 2.41 somewhat. Okay, so that's you approximating. And then the next one is going to be on 3. So on 90 degrees, we are going to be on 3. So just right there, up there on 3. And then lastly, not lastly, actually, we still have quite a number of them. 135. 135, we have 2.41. We are back to that level. So let's just go to that same level that we were before. So somewhere there. And then we are back on 1. On 180, we are here on 1. So that's 1 right there. Again, another point of intersection to notice. Then 225, we're on negative 0.4141. Okay. Negative 0.4, so it's 1, 2, 3, 4, somewhere here. Let's put it somewhere there. All right, and then on 270, we are exactly on negative 1, which is just right there. Another point of intersection. Did you see that one? And then next is our 315, which will be again at that level. Negative 0.41 what. So I'm going to put it, just calculate 1, 2, 3, 4, somewhere there. Okay, so all I need to do is to join this one. It's not a very easy graph to join, so I'm going to start on top here where you can see. So I'm going to, you're supposed to have something of this sort, cutting through that point. Let me see what happens after that. Okay, cutting through that point, then I should join those ones. Okay, so this is precisely how it will look like, cutting at that point and coming right there. That will be your GX. So you won't be able to see the whole thing on one page. For me, it's quite a big graph, but you should have plus minus. On top, it should look like this, and somewhat here at the bottom, it should look something of this sort. So this is what you have this time. So I want us to start thinking about that point of intersection. So this one, luckily for you, if you're in grade 11 and you're watching this, you are not going to do it, you are not going to be able to do it algebraically. So luckily we can easily read the points of intersection. Remember, it's our main focus after we sketch. So our points of intersection, as we are noticing, will be at x is equal to 0 degrees. That is at the beginning there. And here at this turning point where x is equal to 180 degrees, and also just over here when x is equal to 270 degrees. However, I don't want to go, in case there is a metric student watching this as well, I would like you to be able to solve that equation. It gives us a good opportunity to solve that. So what were the two equations? If you still remember, function of x was cos x, it must have been cos x. No, let's just make sure, was it cos x or cos 2x? It was cos 2x. That is the reason you cannot do it, I see. So this one is going to be cos 2x, and then the other function, which is gx, is 2 sine x plus 1. So for grade 11, solving this one might be a bit of a drag, but in grade 12 it's just easy things to do, because you will remember that you have your cos 2a, which can be expanded in 3 ways. So you can say cos squared a minus sine squared a using your double angle identities, or you could say 2 cos squared a minus 1, or you could even say 1 minus 2 sine squared a. So you choose the one that works for you at the time. So in this situation, the situation we find ourselves in, we can see cos 2x, the double angle, is surrounded by sign and numbers. So you take the expansion on this 3 that has got sign and numbers only, not with cosine. So definitely you're going to change that one to 1 minus 2 sine squared a, rather this time is x, and then you say is equal to 2 sine x plus 1, like this. So from here it becomes a non-trinomial, or it's not even becoming a trinomial. Do you see that this 1 and that 1 will cancel? So if I take that one to the other side, it will still be positive like this, and then you still have 0 this side. It's not a trinomial, luckily. So you can just factorize what's common, which is 2 sine x, and then you get your sine x plus 1. I have to mention that please do not divide by sine x on this step here. Don't be tempted to divide by sine x. You'll be losing a solution which says sine x is equal to 0, and you'll be losing some of the general solutions there. All right, so when we do this, we know very well that either 2 sine x is equal to 0 at this point, or you can say sine x plus 1 is equal to 0. No need to write that step. So let's leave sine x as 0 and here sine x as negative 1. Well, we know that there are ways we used as well when we were solving the sine function. We say that to get our general solutions, they are always 2 most of the times. So how do we get the first one? You just really shift on your calculator and do stuff like this and put a 0. So whatever answer you get, I was going to show you, we just are running out of time. So at this point, we're going to get 0 degrees here for this one. If you put 0 in, you get 0 as well. But don't forget to say plus 360k. How do we get the second one on this? You say 180 degrees minus the first answer you got on this step, which in this situation is 0. So you're just going to have this as a general solution. So this right here will be the general solutions you know how to find. And then on the other hand, you also still have to say to find the x value there. Say x sine of negative 1, you should get negative 90 degrees plus your 360k. So at this point, it's also a general solution. To get the second general solution, you say 180 minus this answer that you got there, which was negative 90. So if you say 180 minus 90, you would definitely get 270 plus 360k. So it is these general solutions that you're going to use to calculate all your points of intersection in this situation. So as you are noticing, if you put k of 0 on this one, you get your 0 degrees. So I'm just going straight to the answers. If I put k of 0 on the other one, I can see how I was going to get my 180. The negative 90 is not going to be needed in this situation. So if you put k of 1 on that equation, you can still get 270. Or if you put k of 0 on this one, you still get 270 degrees. So you are going to get those answers anyway using your equations. But this time around, luckily, our graph for all grade 11s, I think they are appreciating the fact that it was easy to find the points of intersection on these graphs. Okay, good. So depending on the graph that you have, you will use a certain method. So as for function of x is greater than 0, I think we talked about it too many times. You just find a time when it is above the x-axis. So function of x happens to be the blue graph in our situation. So I am seeing quite a number of times when, or 2 times, it is from this x value backwards. You can see it is above the x-axis. So I would just say between 0 and what is this number? That should be 45 degrees. That's a solution. Or there is another place when it is above, which is this part. It is still above the x-axis. It means it's between these two x values. So I'll say between x is between 135 as well as what was that, 225. That is you solving for function of x is greater than 0 right there. Very simple if you ask me. Okay, now after you do that, I want us to talk about this last question here, the range one. It's important that we just pass via there, but we already know what this is, but just to make sure you have not forgotten. So we said that if we're determining the range, remember our gx, if I may just remind you, it is 2 sine x plus 1. So what we know for the range, you have to look at the amplitude first. Your amplitude is 2, so y was going to be between negative 2 and 2. in this situation, because the amplitude, which is A here, is 2 right here, but there was a shift 1 unit up because of that +1, so you have to add 1 on both sides of this. So your actual range for this one will be y is an element of real numbers, and y is in between and including what is -2 + 1. Well, I believe you're saying -1, and then 2 + 1 must be 3. So as you can see, the range can be calculated by looking at your A and your C or your Q. That will be the range. However, there are some of us that will go, if you're asked for the range and the graph is there, you go and find the minimum value of the red graph. Do you see that the minimum value is on -1 and the maximum value, look at it, is there on +3. So you are going to get those answers anyway. So before I go, I would like to just give you this exercise. Please answer this one. It was a question paper, and you had function of x there, and then you had cos x, which you were supposed to draw on the same set of x's for those 5 marks. So please notice here your step. You have 2 conflicting steps. I wonder which one you would choose. And then you also have to find the coordinates of the points of intersection. You see it's 8 marks. It means it's not going to be just a straightforward one. And then the period as well as the range. So thank you very much really for watching this video, and if you find these videos helpful, please go to our website, the www.centerofdestiny.co.za, and find out more. Thank you very much for joining me on this one.